The objectives for today's lesson are to learn all about transport and how it touches on so many different aspects of what we do. We learned a word, infrastructure, and we realised that infrastructure applies mostly to transport. So we're talking about roads, bridges, rail lines, cars. Some of the objectives then are to learn about transport as a source of emissions, why transport is important to our lives, and then all the different forms of transport. Through various videos and slides, we want to learn about how an airplane works. We want to learn about displacement and buoyancy. And by the end of the lessons, the kids should have a good appreciation for, again, infrastructure and how it relates to transport, all the different kinds of modes of transport, and then why we need to change from petrol and diesel all the way through to electric vehicles, for example. Extra things to squeeze into this lesson, if at all possible, are talks on safety. So engineers are really concerned about safety, and especially in terms of transport, so that's cars. And we look at how we work on making things simultaneously cheaper but safer. So we have maybe some slides about computational modelling of car crashes, which is really cool. We also have some way of trying to squeeze in some engineering principles like Archimedes. So some of the kids might be familiar with Archimedes, and again, you'll do that in terms of boats. As with the start of most lessons, you're going to ask the kids some questions, try and get some feedback. So you're going to ask for things like other forms of transport that might not have thought of, forms of transport that they're familiar with, how the different kids got to school, and from this form of discussion about maybe talk about New York City or London and how the transport there differs from Cork, maybe get some answers as to why that might be. In the slide about air and water transportation, there are going to be some words that the kids aren't familiar with, and again in the video. So try and pause the video at different stages if you think the class needs it, and write down some words that they might not be familiar with. At the end you can discuss them. If you want to then try and synthesize what it means for a plane to fly versus to fall out of the air, you can talk about simply air particles crashing against the bottom of the airplane, and as they crash into the bottom they push it up. Therefore, as long as you have more air crashing into the bottom than you do crashing into the top, the plane will lift. At the bottom of each slide there is a paragraph of text. That text is really handy for if you're not sure what you want to say in the classroom. You can either use that verbatim or use it to inspire a little conversation amongst yourself and your students. But always know that there's something to fall back on if you're unsure of what to say. The activity one of the activities in the lesson is building paper airplanes. So I took for granted how many kids will be able to do this from the offset. But it can be really, really fun. Try and anticipate a bit of a mess in the classroom because we're all going to want to test them. If you're unfamiliar with how to build a paper airplane, there is a guide in the slides, but really quickly, we'll just do this one. When I'm teaching kids how to do this, I'll try and talk about the importance of symmetry. So if we can talk about how an airplane works and talk about why they need to be the same on both sides, it really encourages them to put a little bit more effort in when they're building. I say as I make a mess of it. So this is your simple paper airplane. Now, exactly as I was trying to demonstrate not to do. So you can see how each of the folds here might be slightly off, and the more off they are, the less straight your plane will fly. So call it a version 1 and a version 2. Really fun idea if the classroom allows for it. It might not be big enough, is to get all the kids to stand on one side, launch their paper airplanes, and whoever gets the furthest wins. Then be sure to pick them all up and put them into recycling. The next activity is building a boat. So you're going to want to leave about 20 minutes or more for this, because don't expect round 1 to work perfectly, and we also want to leave enough time for testing. So if there is a basin available in the school, or if there's a sink at the bottom of the classroom, as there is in many, that would be ideal. We all have a basic cardboard tray. We're going to talk about why this is good, why it's bad. We have our materials from other lessons. So in previous lessons, any materials that have been used up can be kind of put to work here. So things like foam are really, really handy. But before you start building, and even while the kids are building, it's good to walk around the classroom and maybe, even if it seems as if nobody's listening to you, speak about different engineering principles. So our boat here, when you're talking to the students, you want to say, I'll talk about stability. So the wider you make it, the more stable it is. Think of like a skateboard, for example. If you had a really thin skateboard, it'd be hard to balance. You want to use the foam. The foam is good because it traps lots of air. Air is less dense than water, and so it will float. And so the more foam you stick on the side, the more likely it is to float. Tape is really important because it waterproofs your little raft. Ideally, if it sits into the water, no water should leak in the edges, but we know this isn't an ideal world, so we can use... You tape up the edges of the boat like this. It should make it waterproof. Do that all around the edges, put on your foam, and then it comes to the testing. The idea is that you want to carry as big a weight as possible, and going back to the earlier principles of resource efficiency, like whoever carries the most weight without using an excessive amount of foam or other materials could be deemed the winner. Don't focus too much on who wins and who loses, so long as everybody gets something working. As with all lessons, it's really important to go around and make sure that any team that's struggling gets the most help. So some kids will fly off, have a great idea, and be almost finished before you even finish the instructions, and other kids will need a little more help. Okay, so we have our basic idea. We have to try and get as much weight as we can into it without it sinking. We can use things like straws, foam, whatever we want, and some tape. And here is one I came up with earlier. So the idea, again, it's waterproofed, plenty of foam to add some buoyancy, a little bit of a sail just for fun, and you can pack plenty of weight in here. There are going to be things that pop up, for example, asymmetry. So in the same way we spoke about it in terms of paper airplanes, we can talk about asymmetry here. So if the load goes on one side, it's more likely to sink. If we have more foam on one side, it'll rise and fall over. And so the kids, through building a little boat, will learn about trying to make things nice and square. To cater for mixed abilities, the basic lesson is quite simple, but what you'll want to do is, if some groups get finished ahead of time, you can always encourage them to be a little more creative. So, for example, we could use pieces from our previous lessons to try and talk about widening the boat. So if you widen the boat, it's less likely to topple over. If they have specific problems, say for example they want to carry as much weight as possible, you can tell them that you can just add more foam. So give the advanced kids a bit more of a chance to show off. As I said, the basic lesson is quite simple, so every child should get there within 10 to 15 minutes, and then in the last few minutes, especially in testing, invite them to go off and try and make it wider, maybe add more foam, increase the height of the sides, whatever they want to do to have fun. This is the last activity in the lesson, and so afterwards it's just a small bit of a run through of our objectives and clean up time, so you can time that yourself accordingly. So at the end of this lesson, the kids are going to want to know all about the different kinds of transport, how engineers work on making it safer and more efficient and cheaper. And they're going to want to know that airplanes and boats are big complex machines that work on really simple principles that hopefully they understand. And as with always, you can look at the slides for next week's question.